Assalamualaikum warahmatullahi wabarakatuh. My name is Alif Shafiq bin Nur Hisham. My student ID is 2022862154. I am from M3 CS2556A. Today I want to present about my final year project about development of an AI-based tool for targeted image-based detection of gun-generated deepfake using facial analysis. So my supervisor for this project is Dr. Nurul Huda binti Zulkifli, and my examiner is TS Dr. Azlinda binti Abdul Aziz. Okay, now first we go to the lean canvas. So my first lean canvas is problem. My top three problem is: first is limitation of existing detection method, lack of targeted detection, and lack of facial analysis based detection. So for the solution is combine CNN and media pipeline mark detection, region wise attention, grade cam plus grade cam visualization. This is for explainable XAI, and Streamlit based lightweight GUI for real-time user feedback. For the key metric is detection accuracy achieves 97%, model in model inference time per image, and GUI usability score. For the unique value proposition is single, clear, compelling message that state what. For the unique value proposition is a transparent facial analysis driven AI tool that detect gun-generated deepfakes in a real time with visual explanation, outperforming traditional detection method using fusion of CNN and facial landmark. Okay, so for unfair advantage, the first one is custom facial analysis fusion model that combine landmark detection with CNN output. The second one is region-wise heat mapping and integrate explainable AI. So for the channel is academic and cybersecurity conferences, GitHub and open source platform, direct outreach to digital forensic labs and university researchers. For the customer segment is first is cybersecurity analysts, media verification agencies, digital forensic professionals, and educational institution in AI ethics and security. For the cost structure is development and training for basically on GPU computing cost. For the second one is dataset acquisition and pre-processing. The third one is deployment and hosting. For the revenue stream is first one is freemium licensing for educational use, paid version for enterprise users, and custom model training service and API integration for digital content platform. Okay, now we go to the introduction for my final project, which is deepfakes are synthetic media created using AI to mimic real face. GAN, which is generative adversarial network, enable realistic fake face. Deepfakes are a threat to media integrity, identity, and security. So need for a tool that robust and explainable detection tools. Okay, so for the problem statement, first one is the limitation of existing detection method. The second one is lack of targeted detection, and the third one is lack of facial analysis based detection. Okay, so for the objective, is the first one is to develop an AI-based tool for targeted image-based detection of gun-generated deepfake using facial analysis. The second one is to train a set of deepfake data using gun-generated image. The third one is to test the functionality and accuracy using a secondary dataset from 1 million fake face of the developed system. Okay, now we go to the project scope, which is first one is my system is image-based fake detection, just only for image-based. For the second one is face-centric analysis only. The third one is facial landmark integration. The fourth one is explainable AI, XAI integration, and the fifth one is web-based GUI. Okay, for my development tool work, the first one is when user upload a picture. and then is go through to the face detection using MTCNN. After that, facial landmark extracted from the face, which is 468 points using MediaPipe. After that, CNN extract deep features from the image. After that, the fusion of both and make the classification whether the image is real or fake. And then the grad cam highlight attention areas and region wise heat map for added transparency. Okay, so for technology use, the libraries that I use to successful the development tool is I use PyTorch, MediaPipe, MTCNN, ResNet 18, OpenCV, Below, TQDM, Matplotlib, Streamlit. The dataset that I use is real face. For real face is Flickr Faces HQ that I get from Kaggle. Fake face is from 1 million fake face, also from Kaggle. Okay, this is my use case for my development tool. So the actor upload image, analyze, and after that the system is analyze image, detect deepfake, result image, and update model. Okay, now for the flow chart. We have two flow chart here, that for the system flow chart and train AI flow chart. For the system flow chart, user upload image, and then for the pre-processing part, the face will be detected by MTCNN and will be extracted the landmark, the extracted 468 landmark by MediaPipe. After the detection success, it will normalize image, and if the detection is failed, it will skip and sample next image. Go to the sample next image. Okay, after the normalized image, it will convert landmark to the 3D vector, and then uh, after that it go to my system, which is CNN feature extraction, which is using ResNet 18. And then after that, go to the landmark multi-layer perspective processing, which is from 512 dimension into a 128 dimension. And then I go through to the fuse features that concat 512 plus 128 dimension. And then the classifier head weight, which in this part, the prediction is going on with to predict the image whether the real or fake. And then after done the process, it will go to the explanatory modules, which is if yes, will out the output, it will out the grade cam, feature maps, landmark symmetry, FFT analysis, integrated gradient, and the result is. So for the train AI flowchart, start load training data, which is the data set for the train. Load validation data, which is validation data set. Apply pre-processing. Create data loader, that size is 32. Define the model, initialize optimizer using Adam. Start training loop, which I put the epochs for the loop is 10. Forward pass, compute loss, backward pass, update wake, validate model, and then save the best model. Okay, now we go to the project demonstration. Okay. Okay, so for the project demonstration, I have web hosting the my system into internet, that can Google on internet. Okay, this is my GUI for my system, which is Deepfake Cyber Detector. So user must upload the image in this box, which shows browse file, and then it takes firstly we try with the real face. Test with the test dataset that don't have on a training and validation dataset. So we take uh, the real face. Okay, I take this picture. Okay, this is the picture. Okay, so real face detected, confident is 100%. So uh, this show the grade cam and facial landmark. It also have grade cam for the real image for detecting the deepfake. Uh, at the at the at the right, we have also intensity. Okay, so we see here for the region wise, for the jaw is the highest part of the face that detected real, and mouth, and also mouth, which is 10.66%. Okay, now we test with the fake image. Okay, this is my fake image dataset. For testing, I take one picture from the fake image. Okay, so this is show deepfake detected, confident 100%. So we can see here the jaw and the mouth is contribute the highest percent for the deepfake, which is the mouth is 13.70%, and the jaw is 10.92%. So deepfake focus 30.87% of face head of head height attention. So this will show the grade cam show the red one is contributing, the red part is contributing the highest part for the deepfake. Okay, now we test that not a face image. Okay, so I have saved the Toyota Corolla image uh, for testing the system whether it can detect it can detect face or not. So I insert the car picture. So this prove that error during prediction argument of non-type not iterable. So the system cannot detect the car because uh, the car is not a face image. And then I try with invalid uh, invalid folder file, which is PDF, because my system uh, that shows it only can detect from JPG, JPEG, and PNG. So we try with a PDF file. So uh, okay, so I take one PDF file. So this show the carrier application form are not allowed because of the PDF file. Okay, so we can conclude that my system is fully functional, and the accuracy of the detecting deepfake or real face is higher. Okay, so we go to the evaluation. So for the evaluation metrics, we can I testing 10,000 image simultaneously to get the evaluation metric and confidence metric. So the accuracy I get is 97%. The precision for real is 0.98. For the fake is 0.97. For the real is 0.97. For the fake face is 0.98. For the F1 score, for the real face is 0.97. For the fake face is 0.97. So for the confusion matrix, the actual real image that predict real image is 9,679. The real image that predict fake image is 321. The actual fake image that predict real, 186. The actual fake image that predict fake image is 9,814. So this show that the false positive and false negative is lower. Okay, so for my project unit is uh, my AI base is combining CNN and facial landmark. For the I also for my system I also have visual explanation, which is heat maps plus region, and my system is lightweight and user friendly for digital forensic. So that's all from me. Thank you.